An interesting thing happens with geometric series. It is actually possible to add up an infinite number of terms. So even though the pattern never finishes, we can work out its total. Only in a specific situation though. It's known as the limiting sum or the sum to infinity, but it will only work if that ratio is smaller than 1. Well, it could be negative as well, but so in between -1 and 1. So if that happens, what we're basically saying is the limit as r to the power of n as n approaches infinity is equal to 0. Well, how do we know that? It's our exponential curve. It's our exponential curve. The sequence does something which we call converges to 0. So that pattern converges to 0. So even though there's an infinite number of terms, we know that eventually we're going to get to numbers that are so small they may as well be 0. And we're just adding 0 on each time. So we can work out the total. So the limit as n approaches infinity of our sum, putting it into the formula, but we now know that r to the power of n is going to go to 0. And so we get a neat little formula, a on 1 minus r. All we have to do, a divided by 1 minus r will give us the answer. But remember, that's only if that ratio is in between -1 and 1, only if that's true. Now, a question they might ask then, well, will this have a limiting sum then? 56 plus 4 plus 2/7, and the ratio in this one works out to be 4 on 56, which is less than 1. Yes, it would. Now, you get a question like that, whilst it looks like it's just a yes and no, you would want to explain it too. You know, it'd be nice of them to give you a 50-50 chance, but no, they'll be looking for some sort of explanation, justify. Why can you say that? A half plus a quarter plus an eighth. The old frog in the well question, if I was to turn it into a practical one. Have you ever heard about the frog in the well? You got this frog in the well, okay? And it jumps half the length of the well, starts off doing that. But each time it jumps, it's used up a bit of energy. It can only jump half as much again. So it jumps a half, then a quarter, then an eighth. And the question is, does this frog get out of the well? Well, let's see what this adds up to. First term is a half, the ratio is a half. What's our sum to infinity? A on 1 minus r, half of 1 minus is 1. So this stupid little frog does not get out. It gets really close, gets to the edge, but then can only jump a little bit and it never gets out the well. Remember these sorts of questions, right? 0.36 repeater is a fraction, and we saw quick ways of doing it. We now have another way we could do this question, because we could say, well look, 0.36 repeater is 0.36 plus 0.0036 plus 0.000036, and so on and so on. We've got a geometric pattern here. The first term is 0.36, the ratio is 0.01. Sum to infinity, I get 0.36 over 1 minus 0.01, which is 36 on 99, 4 on 11. There's the answer. So yet another way of doing that sort of question. Now be careful. If this had been written as, say, by expressing it as an infinite sum or something like that, then your hands are tied. You would have to do it this way. But if it simply said 0.36 as a fraction, then you can do it whichever way you like. Okay, that will do.